So in this, we are going to look at modular physics, and we shall focus on the first topic, whereby we shall look at forces and motion. Under forces and motion, a few things that you need to understand is a concept to do with average speed, how to work out average speed. And that point, you need to understand that average speed is distance covered divided by the total time taken. You need also to understand the concept acceleration, and acceleration is given by the formula change in velocity over time. You need also to remember the formula final speed is equals to initial speed plus 2 times acceleration times distance, and force is equals to ma, which is force equals to mass times acceleration. So let's look at what has been the questions. What has been the question that have been tested, which questions have been tested in the past, so that you can be able to see how to approach such kind of questions. We're told that this is a car moving along a straight track, and then a car starts from rest and accelerates along a straight race track like that. After crossing the finishing line, the driver applies brakes and the car to bring the car to rest. Right, then you can see now here the car from this point to this region here, the car was accelerating, and then on the other section the car is decelerating. What feature of the graph that gives the magnitude of acceleration? So whenever you are given such a question, because you need to come and check, is it a distance time graph, is it a velocity time graph, or a distance time graph? In this case, this is basically a distance time graph. So which means that if it's a distance time graph, it means the gradient represents the velocity. But if there is a velocity time graph, the gradient represents acceleration. So we're going to say this is going to be the gradient of the line, But the area under the graph is going to represent the distance traveled. Which of the point on the graph does the driver apply the brake? A brake is applied the moment the object starts to decelerate. So at point Q, we are going to say acceleration is applied at point Q. So we are going to say our answer is that. Explain why the graph is a curve in the first 11 seconds. So why is it that the gradient is a curve? So the is moving at an increasing non-uniform speed or velocity, non-uniform velocity. Yeah, increasing non-uniform velocity. In that way, it's at speed is not constant. Speed is changing non-uniformly. Calculate the distance traveled from 11 seconds to 15 seconds. Let's check which section of the graph is that. 11 seconds. So from here, that region to 15 seconds. So which means that we can be able to find the area under this region of the graph so that we can be able to know what that is. And if you can see, the height is actually 90, but the base will be from 11 to 15, so we can be able to subtract the 2. That's going to be 4. So we can be able to say distance is equals to area under the graph, which is going to be area of a triangle, have base and side, because in our case here, the shape that we have is basically a triangle. So we shall say I have base. The base we have is from 11 to 15. So this is going to be 4, and the height is 90. And if you work it out, you can see that this once and this is going to be twice. So 180 meters. 180 meters. We're going to say meters, even though we have worked out area, because area represents the distance in a velocity time graph. Let's look at another question that was tested. What the diagram shows a toy car. We have a toy car moving along a straight track. When the key is turned, the spring inside the car compresses. The spring, because when you're turning the knob, the spring inside the car is going to compress. When the spring is released, the car moves as energy is transferred from the spring to the car, which energy store decreases as the car moves. It's called elastic potential energy store. That's the one that actually decreases, because when you compress your spring, it has elastic potential energy. So meaning that the moment it starts, when the car starts moving, elastic potential energy is converted to kinetic energy, and that's why the car moves. Let's look at another here. Right, so I think I need to add an extra question on that.